Okay, first question is to calculate this angle here, this 100 degrees in radians. So to do that, you take the angle, you divide it by 360 degrees, and you multiply by 2 pi because 360 corresponds to 2 pi. This should give you 1.745 radians. You could have easily done this by doing pi and the corresponding angle, which is 180. That would still give you the same answer. The arc length AB, so this here, this curve, how long is that curve? Well, that comes from the formula you should learn from maths. S is we're going to use for the arc length AB is radius times the angle in radians. So the radius here we're going to say is in meters, 3 meters, right there, times the angle in radians, which is 1.745, which gives us 5.24 meters. Okay, C. Now if he covers this much distance in 20 seconds, the speed is simply, velocity of speed, same thing, is distance or displacement over time. So 5.24 meters in 20 seconds, that gives us 0.26 meters per second. D, the angular speed in radians per second. How much radians is he covering per second? Well, he's covering 1.745 radians in 20 seconds. So that gives us 0.0873 radians per second. The formula we've used here is angular speed equals theta over time. Here is here we've just done r theta, which is arc length divided by time, and over here what's it really? Okay, question 2a. If the balls take 0.125 seconds to do a whole complete circle, what is angular speed? Well, you need to recognize this is a time period because it's the time it takes for one whole cycle, one complete circle is a time period. To get the angular speed, well, you do the angle that is covered in one whole circle. One whole circle is 2 pi. The time it takes is the time period, so you get 2 pi divided by the time period, which is 0.125. Which gives us 50.3 radians per second. Now we turn that into speed. That's how much angles it does per second. To turn it into speed, we have the radius now, 5 meters. So a really useful formula to memorize is velocity or speed equals angular speed times radius. So we get 50.3 times 5, which gives us 251.3 meters per second. And that's the speed he goes around the circle. Where does this equation come from? Well, the velocity is 2 pi r, which is the circumference over the time period. So if you're doing the whole circle, it's 2 pi r, and if you divide by the time it takes, which is the time period, then that gives us the circumference, the velocity. And as you can see, this part here is the angular speed, how much angle is covered in a given period of time. Okay, right. And then last question is question 3. 20 revolutions per minute. So how much revolutions is that per second? Well, you divide it, because it's 60 seconds in a minute, you divide that by 60, you get 3.3 revolutions, we call it revs, per second. 3.3 recurring revolutions per second. That's actually the same as frequency. So frequency is the same as revolutions per second in this case. Frequency is 3.3 revolutions per second. You can even call that hertz if you wanted. You can even use hertz, because at the end of the day is how much cycles or how much complete circles you do per second. To turn that into the time period, the time taken for one spin, you simply use a formula. Time period equals 1 over f. So 1 over 3.3 recurring gives us 0.3 seconds to do one whole